Are you going to be Okay, here we go.
I don't know what the list is.
I can recommend it.
Okay, let's, why don't you move up if you can, get a better spot. I want to take a look today at, okay, quick review of congruent figures. So we want to, in talking about that, we want to be able to identify congruent figures and corresponding parts. Okay, we're going to, you're fine. I mean, you don't have to. If you're comfortable where you are, that's fine. You have good eyes. We're gonna prove that two triangles are congruent in kind of a clumsy way. We'll come up with a much better way soon. But for now, we have to go about it in kind of a not tedious, but it's a little more time consuming and it's a little less efficient way. We'll fix that later. We know more stuff. So identifying congruent figures. Now you guys know this. This is going to be a lot of review here at the beginning. So we know that congruent figures are, congruence just means same size and shape, right? So we could see here that some of these are all congruent because they're all the same size and shape. A way of thinking about that is if I were to pick any one of those up arbitrarily and spin it around and maybe even flip it or something, I could set it down on top of one of the other ones and it would overlap perfectly, right? Not so with these for various reasons. These are different shapes. And like this one is maybe, I guess it's kind of a little bit distorted, but this one, if it were maybe a little bit wider, would be similar to this one. It's the same shape, but a different size, isn't it? So it's also not congruent, okay? Congruency, when two figures are congruent, this is important. There has to be a correspondence between all of the corresponding parts. So for us, that's going to mean sides and angles, right? All those things have to be able to be lined up so that they overlap perfectly. So what about this case right here? If we look at this pair of triangles, we're given a lot of congruence information, right? Does everybody see that we could line up? We have 3 pairs of congruent angles and 3 pairs of congruent sides, right? Everybody, I mean, just to go quickly through this, would you agree that angle A, for example, is congruent to angle P because they each get 2 arcs, right? 2 congruence arcs. And we know that, for example, side BC is congruent to side QR because they each get double hashes. Okay? So if that's true, then how would I say what triangles are congruent here? Somebody. Let's make a congruent statement. Triangle what is congruent to triangle what? Triangles, okay, CAB I heard. That's fine. Is congruent to triangle what? RQP?
RPQ.
Okay, RQP wouldn't have worked. If I wrote it as RQP, that's not true. How come?
Because they're not.
Because I didn't line up the corresponding parts. There has to be a one-to-one correspondence between the angles and the sides in the way that I write the triangles, right? So I'd have to backtrack a little bit here. And I know that angle C goes with angle R, angle A goes with angle P, and angle B goes with angle Q. So that's one way of writing a correct congruent statement between those triangles. What's another way? What if I said triangle ABC? Triangle ABC is congruent to PQR. Now, we don't even really need the picture if I'm given a congruent statement. Let's just say all you have, so don't cheat, everybody just look right up here. Don't look at the picture. Based on that congruent statement only, you're only focusing in the purple box. What side BC must correspond to side QR? Okay, segment CA must correspond to segment RB. Yeah, right? Get the idea? Okay. Okay, there's more than one way to write the congruent statement. usually we would write them in alphabetical order, just because it seems neater, but there's multiple ways you could do it. Okay, so real quick, what would a congruent statement be here? Triangle. Oh, and by the way, I should mention this. So in Moodle, how do you think, I've got the file updated, I think I still need to upload it to Moodle, but how do you think we're going to, in Moodle, write triangle? Triangle, and then in parentheses you put the three vertices, right? Exactly. Okay, so triangle what? DEF. Is congruent to R. Okay, good. Because D goes with R. Good. So we get R, S, T. Make sense? Okay. Okay. So what about this? These aren't triangles. That's okay. They don't need to be. We're trying to solve for X here. Now we're told that there is a congruence in the diagram, and by the way, this is how, when we've got something other than a triangle, if we have polygons that are more complicated than triangles, we just write those as a series of vertices, right? So we're just going to start, for example, in this case we started at N and we just went clockwise around the horn to get all of the vertices in order, right? So this is, by definition, this is some kind of quadrilateral because it has 4 vertices. But we'll get to that stuff later in the year. If we know that this is the congruence relationship, we want to find the value of X. Well, we got to set up, here, let me do something real quick. So, what are we going to do? We want to solve for all the variables, let's say. I got to set up some equations, don't I? I have to pick some geometry relationships that allow me to set up equations in the variables that I'm trying to solve. Okay, Daphne, you got an idea?
Since angle N would be congruent to angle E, you would set 72 equal to
Okay. Okay, good. Good. So we can see here right away that angle N corresponds to angle E, right? And so they must be congruent if the figures are congruent. And so that allows me to set up a relationship, right? We know that congruent angles have equal measures. And so the measure of angle N must equal the measure of angle E, and that gives us 72 equals 7y plus 9, which you guys could all solve. We won't even bother with it, right? You could easily solve that for y. Okay, what about for x? What's the relationship we're going to exploit there? Say it again. Okay, so GH, segment GH corresponds to segment LM, right? Good. So then we get GH is 2x minus 3, right? If segments are congruent, their lengths are equal, right? So then that must equal 8. And we could easily solve for x, right? No big deal. Okay. Okay, how about this? Does it make sense? How many angles are there in a triangle? Obviously 3, right? What do they always add up to? 180. 180. Okay, so then doesn't this just make intuitive sense that if I know that 2 angles in 2 triangles are congruent to each other, then the third ones have to be congruent, right? Because they have to add up to the same total angle sum anyway, right? So that's just the third angles theorem. Okay, if we know 2, then the third angles, it's implied the third angles are also congruent. Okay? Question?
Isn't that more of a postulate? Because our postulate's supposed to be like,
Well, yeah, I did, but this one can be proved based on other stuff, so it's not hard to prove. How would we don't have to go through the whole proof, but how do you suppose you probably would go through that proof? What do you think? Somebody, take a second and just think about this, and then some brave soul kind of just walk us through what your basic strategy would be for probably proving the third angle step. Okay, so we know that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. The measure of the sums of the measures of this triangle would equal 180. Good. What could we do with this statement right here? Angle A is congruent to angle D. Okay, but first we probably have to use the definition of congruent angles and say measures are equal, right? And if the measures are equal, then wouldn't it be true that the measure of angle A plus the measure of angle B must equal the measure of angle D plus the measure of angle E by the addition property, right? Okay. And then if that's true, we could say that 180 minus the quantity measure of angle A plus the measure of angle B equals 180 minus measure of angle D plus the measure of angle E, right? And by the triangle sum theorem, that's equal to the measure of angle C and the measure of angle F respectively, right? So we just proved it, didn't we? Proved that they have to be congruent then by definition of congruent angles. That make sense? You could do it, you could juggle the steps in a bunch of different order, but does the basic idea make sense? Okay. All right, so how about real quick, this guy. Find the value of x. Take a second, got your notebooks, just crank that out. Maybe you don't even need your notebooks. We know what x is?
30. No, x is
15, okay. Yeah, good. How'd you get it?
I just added up the other two angles on L, and then found out that 60 degrees had to be the
Good, good. So all we're really doing, we know we have this equivalence here. We know that if these angles are congruent, then the measures are equal. So this must also be 65. This must be 55. Their sum is 120, leaving you 60 degrees for that angle, right? So then we just have a simple equation. 2x plus 30 equals 60. Solve for x. Good. Good. Okay. Okay. What about this one? Now, I actually kind of want to spend just a second on this one. So, how do you think then that at this point we could prove two triangles are congruent? What do you think?
Two angles on a side.
Okay, eventually you're right. We're going to get to some shortcuts, but for now we don't have any shortcuts for proving triangles congruent. So what's our only way to show at this point that two triangles are congruent? Daphne, what do you think? All the sides are congruent and all the angles are congruent. We have to show that all 6 features, all 6 parts of both triangles are congruent to each other.
We don't have to show 2 angles.
Say that again?
We don't have to show 2 angles
Okay, how come?
because the third angle.
Okay, by the third angle theorem, we get the third one for free, don't we? You're right. So what would our strategy be? Well, we know, okay, we're given 3 pairs of congruent sides. So that's taken, everybody see that? Those guys are congruent, those guys are congruent, and those guys are congruent. So there's 3 of our 6 are done. Check, check, check. What else do we know?
There's that 2 angles are congruent.
Okay, so they're telling us right away here that this angle and this angle have the same measure, so they're congruent. So there's 4 of the 6. What's next? Maisie, what's next? What's another? We need 2 more.
We have to show that the other
two angles like are congruent and have the same measure as the ones on the other side.
Okay, so can you see, we gotta get, these two angles are congruent, are there any other two that are congruent there?
Oh, the two in the middle?
Ah, okay, good, the vertical angles, good, so these two by vertical angles are congruent, and so now, Matthew, we need one more. We've got all three sides and two angles, can we prove that the other two angles are congruent?
Yeah, because we have two.
Okay, good, by the third angles theorem, those must also be congruent, and so we got it by the definition of congruent triangles. Okay, because congruent triangles have all congruent parts, right? Make sense? Okay, good. I'm not gonna focus on, I'm gonna make you guys do a few proofs with this stuff, but I'm not gonna we won't do it today. Okay, what about this one though? This is another good one. Just talking through them is pretty good, I think. So take a second and think about this now. We want to prove two triangles are congruent there. And there's actually more than one pair of triangles we could prove congruent. But let's just take, how about the top and the bottom ones? Yep.
Angle EAB is congruent to ECB.
EC. So say it again. Angle EAB. You said.
Yeah.
Okay. Okay. Good. So angle EAB is congruent to angle ECD. How come?
Because the lines are parallel.
Ah, okay, good. We've got some information here. We see that we've got two parallel lines cut by transversal, right? And so then if parallel lines are cut by a transversal, alternate interior angles are congruent. So what other pair of alternate interior angles do we get? Okay, yeah, good. So if we take this transversal, we get those guys too, don't we? Okay, third angle theorem would be fine. What else could we do there? Vertical angles. Okay. We've got one pair of sides right there. What else? We have to be given, let's see, I think, what are we given here? Okay, here's our given information. Okay, E is the midpoint, right? So if E is the midpoint of BC and AD, what does that tell us? Okay, the midpoint, by definition, the definition of midpoint tells us that each of these two segments must have the same lengths, and therefore they are congruent, right? Make sense? Okay, so we could say this then. We could add some congruence there. We could add that congruence and that congruence, and we got it. What would our final statement be then? Triangle what is congruent to what? Oh, okay, so AEB, A would have to go with C, E goes with E, and D goes with B, right? So it'd be, well, they got that wrong, didn't they? They got that wrong, didn't they?
Yep.
They didn't write that statement down correctly. Everybody see that?
CED.
That should be triangle CED, shouldn't it? How about that? Yeah. Okay. Everybody see that? Okay, if we wanted to sort of break that down into a two-column proof, real quick, let's just glance at this. Here's what it would look like, right? We have, first step is just given. What was our justification for saying that that angle and that angle and that angle and that angle were congruent? Alternate interior angles, there, good. And then these two are congruent. We had our choice of either third angles theorem or, actually, okay, there we go, yeah, third angles theorem or vertical angles. We chose vertical angles. E is the midpoint of those two segments was given. And then we could say that, we said that this congruence right here, right, by definition of midpoint, right? And then finally, the triangles are congruent by the definition of congruent triangles because we checked off all 6 corresponding congruences, right? 6 angles and 6 sides, or 3 sides and 3 angles. Okay?
So is this the inefficient method?
Yes. This is inefficient because we had to get all 6 corresponding parts. In the next section, we're going to look at some shortcuts where we could, if we have just the right combination of 3 parts of each triangle, that's enough. Okay? For example, one of them will be, for example, if we know that all of the sides are congruent, we can show that all of the angles necessarily have to be congruent. So all you really have to do, starting next section, one of our options is to show that all 3 sides are congruent on the 2 triangles. And we'll just call that side, 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 or SSS will be our reason. But we'll get there soon. Okay, I think that's good. We don't need the other stuff. How much time we got?
Yeah.
23 minutes.
Oh, we got a little time? Okay, we'll go to lab.
Awesome.
Okay, let's go to, let me check.